Hey everyone, this is John from EastCoastArmory.com, and I'm here today with a project update video for this 1/6 scale Armortek Early Production German Tiger 1. Since the last video update, a lot of progress has been made to the model's tin work, as well as also some other electronical functions have been completed as well. We'll be going over these additions in more depth in this video. Starting with the model's front fenders, the front fender components that are supplied with the kit are all present here on the table, still in their original packaging. Now, it is important to point out that the Armortek kit, the way the fenders are designed, really haven't changed all that much since the original Armortek Tiger 1 offering back in 2002. The fenders themselves are all comprised of laser cut and pre-bent steel components. We do have some brass fittings for that of the hinges, but there is a certain add-on that I'm going to be discussing, which was included with this version of the Armortek kit, which is definitely a welcome addition, and it's what differs it from the previous releases. Starting with the biggest panel, which is that of the main front fender panels. Like I said before, they are all steel construction. Their hinge pieces are all integrally pressed and bent into the panel, and the way you see it here is basically what you get. Now, there is no under fender detailing. This is something that does have to be added by myself. Moving on from the main panels takes us to the side flaps. Again, same type of quality, which has been found on all the Armortek kits from the past. Same can also be said for that of the hinges. The newest addition is in this little parts bag over here. Now, on the Tiger 1, the way the hinged flap section gets secured in place is via this sliding tab mechanism. Now, these sliding tabs were always absent on the Armortek kits of the past, however, have now been included with the newest version of their Tiger 1. It's a nice welcome addition, like I said before. It is a laser cut piece of steel that has its cuts added, and it's also bent. These pieces here, in the past, I would have to have scratch built in order to get pieces that look just like this. So this is definitely a welcome addition, like I said, to their fender work. Moving on from the front mud flaps takes us now to the rear mud flaps. As for the rear mud flaps, the components that you see here are the kit supplied parts. The ones in the back are made with the same type of fabrication techniques, in that we have laser cut steel for that of the main panels. We have some brass hinges. The difference for the rear mud flaps come in the form of that of the support struts. The support struts that we have here are made from CNC'd bits of aluminum and are designed to be bolted directly to the fender in this manner. With this technique, you get a very basic resemblance of the Tiger 1's rear mud flaps. As for the panels themselves, they are just like the ones on the front, pre-bent, pre-shaped, and they have their little intricate cutouts present. There is also no interior detailing, which is just like the versions again on the front. Now, this being the most current rendition of the Armortek Tiger 1, the difference that this generation has with some of the very early generations has to do with that of the material that these support straps are made of. If you notice, these are made from CNC'd aluminum, and the very original first pattern versions were actually made from a cast white metal alloy. Armortek has been using the CNC component now for a number of years, and basically every other Armortek Tiger 1 kit to come after the 2005 release features these pieces that we have over here. The one relatively recent change, just like with the version on the front, is that with the little hole and the sliding tab plate that we have here, just like what was mentioned earlier. It is from here where I could go ahead and get these components fully assembled and upgraded with better detailing. Moving on from the tin work now takes us to the tank's rear convoy light. The purpose of doing this bit of equipment at this point of the build is that due to the close proximity that the convoy light has with the rear tin work. In addition to mounting the detail to the model, I am also going to be completing the unit circuitry and its function. On all of my 1/6 scale builds, I always have the lights as a controllable feature via the radio, in that you hit a switch and you could activate or deactivate the lights at will. Now, on past builds, I went ahead and utilized a system different from this model over here, which of course I'll be going over in a few seconds. However, before I go into that, let me first go over the actual convoy light itself. The convoy light that you see here is not included with the Armortek kit. In fact, the kit does not supply you with any rear convoy light bit of detailing whatsoever. This is true for all of the Armortek releases that have been released thus far. The component that you see here is an aftermarket piece from Steve Winston. His email address is listed below, and several of his components have already been used on this particular build, not to mention many of the other 1/6 scale Armortek rear control Tiger 1 builds that have been posted on the channel in the past. His components are always highly recommended. Now, as for not this piece is still available, at the time of this video, I am sure this particular bit of kit I acquired a year or two ago when the tank was first started. So as for availability and pricing, that information would be best by contacting him via the email address that I mentioned previously. As for the piece itself, like I said before, it is exquisitely made. We have here the bracket. Everything is metal construction with that of brass. And the way you see this unit here is the way it comes. The unit comes pre-assembled in this configuration. We have here clear glass, or I believe plastic. No, it looks to be a glass tube, like a vial. And on the inside, there's actually a blue light bulb, which is unique in that he still utilizes bulbs and has not made the transition yet to LED. However, for the purposes of this component over here, the bulb is technically better in that you get that nice rich glow of an incandescent light as opposed to the LEDs. These bulbs here are rated to be patched in directly to the Armortek system, so you don't have any chance of burning out the bulb due to the voltages that are found on these models. Everything is fastened together, and overall the piece is a very nice quality. Now, as for the bulb being blue, this is as per the real German tanks. Real German tanks utilize a blue colored light for that of the convoy use, which of course is different from the Americans and the British, I believe, as well. Moving from the convoy light now takes us to the actual electronics, which are going to be used to patch everything in. Now, in the past, in order to have the lights be triggered on and off via the radio, I would have to make this elaborate mechanical electronic switching system. This is usually incorporating a servo as well as an impact switch, and the servo is hooked up to the radio, impact switch is hooked up to the electronics, and when you hit the channel, of course, servo goes, hits the switch, and activates or deactivates the light. It is a simple system, however, the amount of time required to actually fabricate and build the switching unit does become problematic at times. On this build, I decided to go ahead and move away from that older analog style system to the system that we have here. This device that you see here is a direct replacement for that older pattern of analog unit. The way it works is exactly the same in concept. This plug here connects to the model's radio equipment, while these two wires here patch into the actual device that needs to be triggered on or off. As one can clearly see, the advantages of this unit is that, one, it's simplicity. I don't have to actually fabricate the unit. It's basically a drop-in installation. Some other benefits that this has is clearly its size and weight. The unit is much more lower in profile and smaller compared to the analog unit, which even at its smallest I could get it, you are restricted by the size of the actual servo and limit switch itself. Because of that does require you, the builder, to allocate more free space on the inside in order to mount such a device. With something as big as this can be stowed anywhere on the inside of the model that I deem fit. Also, the cost of the unit is very, very reasonable. These units here were acquired off of eBay and can be found in the comments section listed below. As the units come in these type of electronic bags, and they have a little bit of instructions to them. These components here are basically ready to go out of box in the controlled manner, in that the way they are configured out of the packaging, you just simply connect it to the radio control equipment and it allows you to control the unit on and off. There are these two little boxes that we have here that you can swap out, and with any combination of which you can have the unit do certain other tasks. As for the purposes of what I need it for, however, none of these are going to be relevant, and the basic system out of the box should be more than suffice for the application. However, it is something to bring up in case anyone is working on anything radio controlled and might have a different idea to use this device for. This unit here is also rated for 30 volts DC, which is more than enough to cover the type of voltage which is found on the Armortek electronics that are going to be utilized for the accessories. And here are the front fenders, now fully reworked and are ready to go for their priming and then mounting to the tank. As for the components themselves, all the parts that you see here are basically supplied with the Armortek kit like I showed before. This includes, of course, the fender panels, the hinges, and even the slide bar. What was added is not necessarily what's on the outside, but more what's on the underside. With the front fenders flipped over, here you can get to see the underside detailing of these components. Now this is a bit of detailing which is very specific and unique to the Tiger 1, is that the way the panels were fabricated. On the real tank, the tin work was actually comprised of flat pieces for that of the two panels, and then for the edging, these were actually fabricated out of strips of angle iron. The angle iron would then be mounted to the flat plates, which would give you your lip, which you would see across the edges, but it would also give you the rigidity needed for this type of a component to prevent it from getting damaged or make it less likely of getting damaged in field. Now to do this modification, I went ahead and utilized strips of brass. Now this type of procedure I've done on several other builds in the past, and they can also be found in the other videos on the channel. Basically, I take strips of brass and I solder them in spots to that of the plates. The spot soldering is required in order to really give a nice strong bond for these components and make sure that they don't fall off specifically over time. As for the other assistance with that of the mounting, you'll notice that the pieces are riveted in place. These rivets that you see here are real aluminum dome-headed rivets, which were drilled and then stamped into their appropriate locations. The rivets give you more structure holding, but it also gives you the detail element of the rivet sections, which would be found on the real underside of the piece. This is true for the entire thin flip area, as well as the front section as well. Now, in addition to adding those details over there, you'll also see I added another strip of steel to simulate the other section of the angle iron, which would have been found in this descended location over here. As for these sections over here, these are the stock Armortek ones that were integrally pressed into the plate as before, and rather than trying to cut them off and redo this type of detailing, I left it stock and I just simply mounted the inner detailing for that of the strip. This gives you the illusion that the piece is made from the angle iron piece. Now, if you notice, all of the pieces are, again, fastened on with that of rivets, with the exception of these two rows over here. Purpose of that is for that of the hinge work. The hinge work on the Tiger 1 fender was only done with that of slot screws, and were not held on with rivets. In order to do this, I simply use real miniature slot screws and fasteners. Everything, of course, is Loctite in place, and they are not going to be coming off anytime soon. Another mod that I had to do was to the hinges themselves. The stock Armortek hinges only had 4 locations for mounting on fasteners. There were 2 on the ends, however the centers were absent. When doing the modification, I went ahead, once everything was bolted in place, nice and firm, on the drill press I drilled out the last 2 missing locations, and then simply just mounted on the same fasteners from before. This completes the look of the hinge and definitely improves its accuracy. This, needless to say, was done on both sides. In addition to the hinge work, I also added this little tab that we have here on the front leading edge of the fender. The purpose of this is that on the real Tiger 1, this is where the hook would connect to and would strap the front fender and keep it down in place. Think of it something along the lines as like what you would see on a Jeep. On the hood of a Jeep, there are these little hooks that come up and keep everything fastened down. Tiger 1 had the same system for its front fenders. As for the sliding bar, this is the Armortek unit. And like I said, this was a nice little addition and saved me time having to fabricate this out of brass. What was done was that a brass hex bolt was soldered directly to the panel, and this is very similar to the real Tiger 1. There was a real bolt which would have been welded to this location for this exact same purpose. On the real tank, you would have a wing nut which you would tighten or loosen this little sliding bracket in place. The purpose for this bracket is that once it is fully extended and the fasteners clamp down, this will prevent the flap from fully hinging open when the tank is in operation. And then when you want to flip this section up for when you're in transport mode or when you put on the thinner transport track, you would loosen the fastener, slide this plate out of the way, and now the piece can fully hinge up. In order to keep the hinge plate in place, you notice that there's a small little receptacle that we have over here. This was a component that was fabricated out of a little strip of steel, bent and soldered in place. Once everything is added, the units are then fully completed. Now at this time, it's also important to point out that there are a few different variations of these little retention systems that we have here for the front fender. The one you see here is one that I've seen from a few Tiger 1 examples taken during wartime photographs. However, if you look at the Tiger 1 in Bovington, the design is slightly different in which there is a flat plate welded to the front fender panel, and the latch here would actually have a small little flat on it, and you would adjust it accordingly. That design is doable. However, this design here I prefer in that it does a better job in locking it in place from my experience. Now finally, you'll notice that for the fastener I used a flexible Recen fastener. The reason for this has to do with the location that this is in. Having a standard Recen component will be very problematic in that it's brittle and frail, and something like this can still be semi-functional with it being this rubbery material in that it clamps down on the threads of the piece, and if anything were to brush up against it, it will simply just flex out of the way rather than just snapping like a traditional Recen component. Now from here, these pieces are going to go immediately into primer. The reason for that has to do again with this type of mild steel construction for that of the fender panels, and also with the type of soldering that was done. These pieces here are going to be very prone to that of rusting, so as soon as you're done with the conversion, you want to get them into its base coat. Now, let's just say you did all the soldering, but you didn't have the rivets on hand and you had to wait for them to come in from the supplier, like yours truly. You will develop some surface rust on these components. However, it's a very easy type situation to fix. Just before you go ahead and install the fasteners, you simply take some sandpaper, buff down the surface rust, and just wipe it off with a wet paper towel of turpentine, which is exactly what I needed to do. And as you can see, the piece is cleaned up very well. However, from here, like I said, they're going to go immediately into primer, and then they'll be mounted to the tank. And here are the front fenders now mounted to the model. They are mounted to the stock Armortek hinges, which were showcased in an earlier video update, and simply just pin on. Now in the front here, I have the EastCoastArmory.com Tiger 1 front fender retention hook. This hook here, via that small little latch that I mentioned earlier, locks the fender in its closed state and prevents the mud flaps from flopping around during operation. Now these are functional on the ECA set. I just simply pop it out of the way. If I zoom out, the front fender can now open up. And of course, the fender's flip-up corner section here is still fully functional via that little black flex Recen wing nut, which gives you both the detailing and also the actual method of how the piece is retained. And here are the fenders just before they go into prime. At this point here, all of the modifications have been made and all of their detailing has been added. The only thing currently that are missing off of these two mud flaps here are the little wing nuts, which will be that rubbery Recen material that I showcased earlier. Those will be added after the pieces are painted. As for the fenders themselves, they are predominantly made with the components which were supplied with the kit that I showcased earlier. Starting with what was kept from the kit, the main panel and the side panel were kept along with the two hinge work. What has changed are that of the rigidity ribs, which are found on the two sides here of the fender itself. If we can recall, the kit ones were the CNC'd aluminum units. In their place, I went ahead and replaced them with sheet metal ones, which were scratch built, and then were soldered directly to the plate. The sheet metal ones are more to scale compared to the standard Armortek units, and also they don't have this fastener which would have been found on the Armortek ones, which would not be present on the real units. On the real units, these were welded directly to the plate. Now, in order to swap out the piece, I also had to modify the hinge mechanism on how the piece actually connects to the tank. Now, the Armortek system is basically very similar to the real Tiger 1, but has been simplified a lot further in order to make it robust and also to make it to the point where it's more easily constructed. Because this is a radio control tank, and because these do need to be very robust due to their locations where they're constantly going to be affected by debris being kicked up from the track, or possibly even from getting bumped around due to the way they are a snag point, rather than redesigning the hinge, I went ahead and did the same procedure that I did to the last Tiger 1 I did, in which I dress up the stock Armortek hinge, so visually it looks just like the one on the real Tiger 1, but has the same functionality and robustness from the Armortek kit. The way this was done was that, of course, I went ahead and removed these units. Now, if you notice, there is a small little hinge built into these sections over here, which would then have a steel rod connect everything together. Because those pieces were no longer used, the hinge was changed to just this brass tube that we have here. The brass tube has these small little ridges machined into the section, which give it the look of that of a hinge, and with the way it is sized, this will still mount directly to the Armortek hinge mounts, and will conceal that of the steel pin, or rod I should say, which will go and lock everything together. This will then give you the look of the correct hinge, and will still be fully hinged and be fully functional. This was done to both fenders that we have here. Moving from the hinge mechanism, now takes us to the flip portion of this component. Just like what was mentioned in other videos, because the Tiger 1, when it will be fitted with the thinner transport tracks, the outer layer of wheels along with the outer fenders would be removed, and this section here, and also the one in the front, would then pivot upward. This is why these tanks do feature this feature. As for the piece itself, I went ahead and, just like on the front fenders, added the under portion detailing. Now, for the main panel itself, there's nothing under here, even on the real vehicles, just a smooth panel. However, on the flip-up portion, there is a miniature little box frame, just like it is on the front. Just like with the version on the front, the same method of fabrication was used. Brass strips were soldered to the metal, and then rivets were then added and smushed in their places, which give you, again, the detail for that of the riveting on both sides, but it also gives you more strength because, again, this is a portion of the model that will be prone to that of dirt and debris and possibly snagging. As for the hinges, they are bolted to the piece, and if we notice, I use the same dome-headed slot screws as before. And these are, the kit supplied hinges, and were simply mounted as is. As for the lock tab, this was supplied with the kit. However, I did not utilize it for the rear fender. The rear fender lock tab is very similar in design, but has slightly different dimensions compared to the one on the front, which is what Armortek just went ahead and mirrored. The ones in the rear are longer, and if you notice, they have two tabs on them. This unit here I fabricated out of some brass strip and simply mounts to the location that we have here. Now, with the way it's designed, you'll see that it has a tab that flips up and is butted up against the support rib. The purpose of this is that this locks the unit in place and prevents it from flipping upward. When it comes time to actually flip it up, you would loosen the wing nut, slide this unit all the way to this section over here, tighten the wing nut, and then that little tab also acts as an overstop, so it prevents the piece from overhinging. And we'll butt it up perfectly at a 90-degree angle. Of course, more of this will be discussed once it's mounted to the vehicle. At this point here, I could go ahead and get the pieces into prime and then installation. And here's the rear fender now fitted to the tank. The other fender has also been fitted on the opposite side, and we'll go to that one in a second. But basically, it's the exact same type of application that you see here. Here you can see, now fully primed, the hinge mechanism, now fully painted, and it, like I said before, it gives you the look and feel of the hinge. However, it's still mounted in the standard Armortek way with the Armortek mounting pin. This gives you a nice, strong mounting. This piece here is still fully functional. If I move this guy out of the way. Oh. There we go. If I open up the hinge, you can see the piece is still fully functional and is more than durable enough to take anything that would be kicked up by the rear sprocket. And just like the version in the front, the folding section is, of course, still fully functional. Now, moving to the mud flap on the left-hand side of the vehicle, this, again, is mounting it with the exact same mounting procedure that was done on the right. The only difference is that on this one here, you can see that it needs to have the clearance for that of the tubular taillight that was mentioned earlier. In order to do this, the piece was a very close fit. I just had to open up the tolerances slightly on the sides, just so that it clears the aftermarket light in the way you see it here. It makes absolutely no contact with the piece, which is exactly what you're looking for. Now, as for the light itself, like I mentioned before, this is connected to the tank's electrical system and has a new pattern of remote switch. Right now, the switch is totally hooked up and connected to the radio. Tank is on, and when I hit the switch, the light works. The system was a very easy hookup as per the instructions that I showed before, and this system is definitely recommended for anyone who wants to have some kind of a remote activated animation or light or anything like that on their radio controlled model. Now, moving back to the inside of the model, like I said in the last video, the main instrument panels are going to start fleshing out with that of its controls and switches. This switch here is one of the first. This switch here is the main master kill switch for that of the lights. The purpose of this switch here is that this allows the operator to run the tank without any risk of the lights being turned on. Why this is important? Well, if the tank is being driven and the radio switch for lights or the activation switch is accidentally bumped by the operator, the lights will not turn on. Why this is important is that in case you want to save on battery power, or more likely you also want to save on wear and tear of the bulbs and LEDs themselves. That's what this switch here offers. Now, of course, I'm going to be labeling what all this equipment is as the build progresses, but here we go, it's just a simple on and off switch. This way is off, and this way is on. Now, this feature may be something I might phase out on future builds, but at the moment, it's patched into the tank's electrical circuitry. With the front and rear mud flaps out of the way, I can now focus on that of the tank's actual side skirts. Now, for the side skirts, all the components that are supplied with the Armortek tank are right here on the table. The only components that are not on this table here are the small little mounting bosses which connect the tin work to that of the side of the hull. Of course, this was discussed and showcased in more depth and detail in a previous update video. Now, as for how the parts are supplied with the Armortek kit, these components here are literally untouched since the first Armortek Tiger 1 release back in around 2002. It's one of those things where they got right the first time, and they've basically been making them to the same standard ever since. Starting with the side skirt panels themselves, they are two size sets that we have here, the shorter and the longer. This is as per the real Tiger 1, and when it comes time for mounting, you'll see exactly which panels go where. As for the sheet metal work themselves, They are laser cut steel and are pre-bent to the correct shape for that of the production version of the Tiger 1 fenders. Now these fenders here are different from the earlier initial production Tiger 1 fenders, which were added to the Tiger 1s in North Africa. They look similar, however the African Tigers have a slightly different profile to that of the tin work. However, that's not necessarily important for this video. As for this version here, this is the basic type side skirts that you would see on Tiger 1s from the early all the way up to the final production runs. In addition to the sheet metal work, the kit also supplies you with these end sections that we have here. The end sections are made from, again, laser cut sheet steel, which are pre-bent. And the purpose of these are for the first and last side skirt panels that are found on each side of the tank. These get affixed to the side skirt panel in this format over here. Now, if you notice, there are no fastener holes on these locations. The kit recommends that you epoxy these components to the fenders. However, for my builds, I don't use epoxy. Instead, I actually solder it directly to the side skirt panels. The soldering gives you a very strong bond, and it also gives you a very realistic weld bead that mimics that of the real pieces. Keep in mind, on the real tanks, these were thin little pieces of sheet metal, which also were then welded to the side skirt panels. These pieces are very similar to the original production run, but the difference that you see on these ones is that they are two small little holes. On this kit here, you can bolt this component to the actual hull of the tank, and then when you mount the side skirt on top of it, it would just sit over the piece in this manner. This is a nice touch, specifically if you are not using the soldering method, and if you're only using that of adhesives, that something like this can easily get pinged and knocked off due to the type of debris that got kicked up by the tracks. However, this is not necessary if you're building the tank like I am with that of solder. Now, if someone does have the type of tooling and the skill to use that of welding, you can actually weld these pieces to the sheet metal components over here. However, this is something that is just a different option compared to the solder method that I'm going to be using on this build. Now, even though these pieces will be used, there are some mods that are going to be going into these pieces which make it a little bit different from that of the stock kit offering. The first has to do with that of the actual fastener holes on top. If you notice on the stock Armortek kit, this is just continuous with the bend that we have directly over the holes. This is basically like this on most 1/35 scale and larger model tanks on the market. However, on the Tiger 1, this is actually not the case. On the Tiger 1, the little pieces of steel directly over the fastener sections here are actually missing and are cut out. This is going to be added to all these panels with that of a Dremel with a cutting stone. This greatly improves the look of the tank compared to leaving it stock, and it's one of those details where in smaller scales it's not really that noticeable, but however, once done on a 1/6 scale model, definitely pops out in the photographs and definitely helps the realism of the tank and definitely improves the detail over leaving it stock. Another detail that I'm going to be adding is that of the interior panel. If you notice on the tin work here, the inside panel has absolutely no detailing present, which is common on most tanks again on the market. However, on the Tiger 1, there were a series of rigidity ribs and bulkheads which were welded to the inside panels, which gave the side skirts a lot more robustness. As one can imagine, a panel of sheet metal like this can easily be banged and dinged up with simple operation, let alone combat. So the Germans went ahead and had bulkheads added to these sections here to help up with the rigidity. These will be added and will be fabricated out of sheet metal and then, again, soldered directly to the plate. And here we have the bulkheads laid out on this piece of sheet metal. As for the bulkheads themselves, I went ahead and traced them from this paper template that I have over here. This template was scaled off of some reference material that I have. The template was traced onto the sheet metal with that of a Sharpie. And then from here, with aviation snips, they're going to be cut off and then refined further with some hand tools. From that point on, they will then be soldered directly to the sheet metal panels. And here goes the Fender going through its modification process. The first thing I'm going to do is cut out the little notches that I mentioned before. Now, as for their locations, I simply just went ahead and marked them with a Sharpie, and they're going to be cut out. The way I'm going to cut them out is with that of a Dremel. For the bit, I'm going to be utilizing a cutting stone, which I'll be using to cut into the steel to remove the little sections desired. Now, as for the amount of cutting required, this, when I first started the job, was a brand new Dremel reinforced fiberglass cutting stone, and this here is the last fender, so you can see that one stone is basically enough to complete the entire tank. Now, in addition to using the Dremel to cut out the squares, the Dremel is going to remove the majority of the material. As for the final refinement, this is going to be done with that by hand with the use of a square file. This will be shown after I go ahead and cut out these little locations here. And the first notch is cut out. I'm then going to repeat the steps. Now, it's needless to say that this does create a lot of sparks, and eye and breathing protection is recommended doing this procedure. And here is the panel now with all the cutouts made. Like what was showcased before, the Dremel does do a really good job, but there is still some cleaning that is required. For the refinement, a square file is going to be used, and I'm just going to go ahead and grind down the necessary material by hand. This is done until each of these little squares are at the correct smoothness and shape. Like that one over there. I'll now go ahead and do the exact same procedure to the remaining slots. With the squares now all refined, with a larger file, I'm going to go ahead and go up and down the surfaces on both the inside and the outside to remove any burrs that remain from both the dremeling and the filing procedures. Some swipes of sandpaper can also be used to further smooth down the surfaces. And like that, the panel is now modified and it's ready for its next step. After the cutouts and refining are done, the next step is to add the bulkheads. Now, like I said before, there are two types of fenders on the Tiger 1, and within those two types, there are also two more variations. You have the short and the long, and you also have the center portions and the end versions. The difference, of course, being is that the ones in the center have 3 small rigidity ribs, and the ones on either end have 2 of the smaller ribs and 1 bigger end plate that's either on one end or the other, depending on if it's for the front or rear of the tank. Now, the ribs have been cut out since the last scene and have been ground down and are ready for installation. Like I said before, I'm going to be soldering these pieces to this plate. Now, to do that, first with a pencil I went ahead and marked the locations where the 3 ribs are going to go. And before I could even do any soldering, what I need to do first is with a Dremel, with, again, a cutting stone, I'm going to go and score along these areas over here. What the scoring does is that this helps the solder and the flux fully grip and bond onto the metal. If you just try to solder regular steel, or brass for that matter, to this type of metal, you're going to have a more difficult time, as the surface really needs to be scuffed up. With the scuffed up surface, this really helps the solder and everything else fuse a lot better than without. With the scoring done, as you see, I don't go ahead and cut directly into the piece with the cutting stone. I just glide the cutting stone over the surface just to get this type of abrasive type look that you see here. This is very similar to when you actually do some welding. You need to do a similar concept for basically the same type of outcome. With the pieces now scored, it's now time to add the flux. Now, as for the solder and the flux that I'm using, for all of my builds, I actually use just basic electrical solder. I believe it's 60-40 or 60-20 if I'm not mistaken. This material here I use on everything from my electronics to also soldering brass and brush guards and also fender work. For the flux, I use just a tub here of plumbing flux. I'm going to apply the flux first to the piece. Just get a nice little smear on there. Now you don't want to have the piece just caked in the flux, just a little smear should be more than suffice at helping the solder flow once fully heated. In addition to smearing the flux on the fender, or side screw panel I should say, I also go ahead and dip some onto the bulkhead itself. Just line up the bulkhead, and the flux kind of supports it. Now, as for the application, for this job I'm going to be utilizing a soldering iron. This is also the soldering iron that I use for basically all of my soldering needs. It's a very affordable and easy to find soldering iron, and it definitely outputs well above its weight. Now, you can possibly use a blowtorch. As a matter of fact, I have used blowtorches in the past, specifically when the soldering iron is either older and it doesn't output enough heat, or if it was broken at the time and I was waiting to get a new one. A torch will work, but there is some more complexities in that you have to heat the metal and then you have to cool it down. And you have to keep sections cool when you're heating other portions of it. This can cause a little problem with some solder melting on you in certain spots. But it is doable. Another caveat to the torch is that due to the more heat now being exposed to the steel will have a tendency to rust in a quicker manner. This isn't a problem if you go ahead and quickly get the pieces once they have been soldered. You go ahead and get them in their coat of primer, which will protect the bare steel and prevent any sort of surface rust forming. With the soldering iron, due to its pinpoint location or application of the heat, the pieces can go a little bit longer without the need for priming. However, priming is still going to be a process that all of these pieces go through. Without further ado, I'm going to go ahead and start the soldering. I like to first basically kind of like tack weld it in a certain spot, like here on the end. Make sure it's lined up. As for the alignment, I'm basically just eyeballing it, and you could see very quickly if your piece is on in a straight line or not. If you really want to have these pieces and be as straight as possible, you can possibly have a small little angle guide if need be. However, from my experience, it's not necessary. You could simply just eyeball it and get everything basically squared away. After the pieces are tacked on in their two locations, it's then time to do the actual soldering itself. I just go through and basically create a weld bead of molten solder. And here's what the bulkhead looks like now soldered in place. As you can see, it's nice and strong. And you can see the little miniature weld bead that was created from the production. I already started the procedure for mounting on the second unit. Flux has been added. Piece has been dipped. And I'll start the soldering process again. There we have it. Second one down. One more to go. The last bit to add is that of the end plates for that of the side skirt panels. Now, one mod that I'm doing is I'm deleting the little fastener plate that we have here. Like I mentioned before, this was added recently by Armortek, so you could fasten these plates directly to the side hull of the tank, and then you could mount the side skirt paneling over it. This gives you the illusion that these pieces are connected, but it makes it a lot more simpler to install for someone who has a more simplistic set of tools and doesn't have the experience in either welding or soldering like I'm doing over here. For a casual builder, this is perfectly fine. However, for this particular build, that's not going to be necessary. And having this along with the other pieces, it actually then hurts the look. So what I'm going to do is with a Dremel, with a fresh cutting stone, I'm going to go ahead and amputate these sections here from all of these panels. After a few swipes, the piece is removed and it can now be mounted to the tank. As for mounting, this section here is the portion of the panel which actually makes contact with the side skirt panel itself, and this is where I'm going to do the soldering. Now, if you notice, I already went ahead and mounted the two smaller ribs to this panel here with the same procedure that I just showed. For these ones here, if you notice, I scored a little bit more of the material due to the longer width here of this part. Before I could get this soldered on, since this is made with the same type of metal as the side skirt panel, I'm going to go ahead and scuff it up with that of a cutting stone as well. With the piece now scored, I can then do the soldering. And here are the side skirt panels with their mods fully completed, and from this point here, they're ready for their coat of primer, base coat, and then of course weathering and installation. As for the surfaces, you'll notice that there is some surface rust developing. Now, this scene here was filmed approximately 3 hours after the scene where I was soldering the last component onto this part. Even though a blowtorch was not used, because of the flux, wherever the flux made contact with the sheet metal, some surface rust will develop. Now, this is of course not an issue. Some swipes with some sandpaper will easily remedy this situation. Now, if this was done with a blowtorch, because of the extra heat, like I was mentioning before, the surface rust would start developing in a much sooner and possibly even a more accelerated rate. However, this is nothing to stress about, as again, it's only on the surface. Before you put the pieces with their primer, just hit it with some sandpaper, and the pieces will be good to go. Now, unfortunately, I'm not going to be able to get the pieces into primer tonight, as right now there is a rainstorm outside of my house. So as soon as the weather clears up, I could get these guys into primer, and then, of course, installation. With these details and tin work out of the way, I can now focus on the remainder of this side hull detailing, which of course is going to include the side skirt panels, as well as also the track removal cable, which will be located in this section over here. Of course, more information on that is to come in the next video update, along with more other electronic gizmos that are going to be fleshed out on the interior portion of the model. And with that, that wraps up this project update video for this 1/6 scale radio-controlled Armortek Early Production German Tiger 1. If you like this video, stop by and like us on Facebook, where there are more photographs of this particular build that have been posted since project start, as well as the other smaller and larger scale builds that are found on the ECA channel. Furthermore, don't forget to swing by eastcoastarmory.com for more 1/6 and 1/16 scale builds and detail components. Thanks for watching.